230 million years ago, the Earth broke its silence. The deserts of Pangaea, vast as entire continents, baked under a merciless sun. But then, the heavens shifted. Storms gathered, storms unlike anything the planet had ever known. And when the first raindrops fell, they did not stop. Not for a season, not for a century. For nearly 2 million years, the skies wept without end. Forests drowned, rivers swelled into inland seas, and entire landscapes dissolved into mud. Acid rained from volcanic skies, leaching the soils and poisoning the waters. Oceans, once cradles of life, turned black and suffocated in silence. Half of all species disappeared, their empires erased as if they had never been. Yet amid this chaos, a strange paradox unfolded. From the wreckage of extinction, one fragile lineage found its chance. Small, nimble, resilient, the creatures we would one day call dinosaurs. They stepped into the silence after the storm, and in doing so, claimed the throne of Earth for the next 100 million years. This is the story of the storm that nearly ended life and the deluge that gave rise to giants. Prepare for a journey into the rains that rewrote creation itself. We begin. Close your eyes and step back, not by centuries or millennia, but by more than 230 million years. The Earth you find yourself upon is not yet divided into the familiar continents we know today. There is no Atlantic Ocean, no delicate scatter of islands, no patchwork quilt of nations and seas. Instead, a single body of land stretches from pole to pole, an ancient titan called Pangaea. It is immense, seemingly endless, a world so broad that to walk across it would be to wander through lifetimes. But grandeur has its price. In the deep interior of this colossal continent, far from the life-giving margins of ocean, water is a stranger. Vast deserts sprawl where rivers cannot reach. Winds carry heat like invisible fire, and sand moves in restless dunes, sculpted by a sun that seems never to yield. Imagine air dry enough to draw the breath from your lungs, days when the sky burned like bronze, and nights when the land cracked with chill because there was nothing to hold the warmth. Life has learned to endure, but endurance here is cruel. The Triassic world is one of specialists, creatures built to survive scarcity. Early reptiles with armored hides creep along the edges of dry floodplains, their bodies conserving moisture with the precision of machines. Plants cling to the margins of rivers that vanish without warning, their roots probing deep in search of groundwater, their leaves adapted to waste nothing. Amphibians linger in rare pools, waiting for rain that may not come for years. This was a planet balanced on the knife edge of drought, a silence of thirst held in fragile suspension. You might think of deserts as barren, but here they hold a strange vitality. Herds of ancient herbivores roam, shaped like nothing you would see today. Rhynchosaurs with powerful beaks, archosaurs with long limbs and crocodile-like jaws. Their tracks score the sand, brief ray, ecords soon erased by wind. In the canyons, rivers flow in short-lived torrents, carving gullies only to retreat and leave behind cracked beds like scars across the earth. In this world, stability is an illusion. The climate is hot, yes, but more importantly, it is uniform. The rains are rare, the droughts predictable, and ecosystems adapt to this rhythm. Evolution rewards those who can endure monotony, who can cling to the margins. The desert is not chaos, but a steady hum of survival. Every species tuned to scarcity. The silence of the skies is itself a constant. It is this silence, this strange, dry peace, that sets the stage for what is to come. But even as the deserts spread their wings, cracks are forming in this stability. Deep beneath Pangaea's crust, pressure gathers. Magma pools in hidden chambers, a restless tide of molten stone preparing to burst. Though invisible to the creatures walking the surface, the earth is stirring. The air is not yet heavy, the skies not yet dark, but the seeds of transformation are sown in the bowels of the planet itself. Picture yourself standing on one of those arid plains, the horizon shimmering with heat. To the east, the land swells slightly, the earliest tremors of a fault line that will one day split continents apart. You hear nothing but the whisper of wind, and yet the future presses close. Volcanic convulsions that will scar half the globe, storms that will drown deserts in unrelenting rain. But for now, only stillness. This stillness is deceptive. The fossil record shows us that diversity at this time is strangely fragile. Many groups of reptiles flourish, but others teeter on the edge of extinction. The world is not yet dominated by dinosaurs. They exist, small and light-boned, but they are background players, overshadowed by the heavier, stronger creatures of the day. It is a world of competitors, each adapted to a narrow, ecological stage. The balance seems steady, but one shift, one disruption could collapse entire networks of life, and disruptions were brewing. Geological evidence tells us that atmospheric carbon dioxide during this period was already high, perhaps 4 to 6 times higher than modern levels. That CO2 thickened the atmosphere, holding in warmth, making the deserts harsher, the interiors hotter. Yet even with such greenhouse air, Pangaea's immensity meant dryness ruled. The rains that did fall were trapped at the coasts, and the heartland remained starved. Imagine forests locked on the edges of the world, while the central plains lay abandoned to sand and scrub. Here, survival was not only physical, but chemical. Soil nutrients, stripped by sun and wind, forced plants into resilience. Rivers carried minerals in fleeting floods, and life followed them desperately. Ecosystems rose and fell with every drought cycle. You could say this was a world already rehearsing collapse, though no creature alive then could have known how severe the performance would be. Oddly, some scientists believe that even in this dry age, whispers of moisture came in irregular pulses. Sediment records hint at sporadic shifts, strange, brief, humid intervals that appeared and vanished. Was the Earth testing its own balance, experimenting with the power of rainfall before unleashing it fully? Or were these simply local events, lost to time, mere ripples in a sea of dust? The debate remains. What is certain is that stability was never permanent, and fragility always lay just beneath the surface. And so, the Triassic desert world sits in our memory as a paradox. It is a place of silence, of heat, of scarcity, and yet a place brimming with potential energy. The very uniformity of its climate made it vulnerable, its deserts ripe for upheaval. Like a bowstring drawn tight, the system waited only for the release of tension. When the rains came, they would not simply arrive, they would break, and the bow would snap. See your eyes once more. Feel the heat rising from stone that has baked for centuries. Hear the dry hiss of wind moving across sand. Look at the horizon where the sky burns pale and thin. This is the last breath before the world changes. For millions of years, Earth has been parched, its lungs filled with dust. Soon, it will inhale moisture, and it will not exhale again for 2 million years. This desert silence, this vast, arid stillness, is the overture to a symphony of storms. And like all overtures, it is meant to deceive, to lull, to prepare you for the moment the orchestra begins. The stage is set, the players are ready, and the first drop is about to fall. Imagine standing in that parched silence, the air brittle, the land trembling with heat. For millions of years, the sky has been little more than a mirror of fire, unbroken, pitiless, blue so pale it borders on white. Clouds, if they appear at all, are wisps, illusions quickly torn apart by dry winds. But then, one day, not a day marked by calendars or clocks, but a geological heartbeat, the sky begins to change. The horizon darkens. Not the gentle shading of twilight, but a bruise spreading across the heavens. For the first time in countless lifetimes, vapor thickens above Pangaea's deserts. The air grows heavy, a weight pressing down, rich with a scent almost foreign, petrichor, the fragrance of rain meeting dust. Imagine creatures lifting their heads, blinking in confusion, nostrils flaring at a smell their ancestors may never have known. And then, sound, not the whisper of wind, but the low growl of thunder, rolling over dunes like the voice of a buried god. Lightning scars the sky, brilliant veins of fire splitting clouds swollen with water. And at last, the first drops fall. To us, a raindrop is ordinary. To them, it was revolution. Each droplet strikes the baked earth with the sharpness of a drumbeat. The soil hisses as if in pain, the crust breaking open to swallow what little it can. Amphibians, waiting half buried in mud, stir to life, their bodies vibrating with long-forgotten rhythms. Reptiles taste the air, sensing opportunity. Plants, brittle and withered, feel moisture creep into their roots, a signal to awaken. But the rain is not fleeting. It does not end with a passing shower or a day of storms. Instead, it builds, each day heavier than the last. At first, rivers swell and fill long empty channels. Canyons echo with the roar of torrents. Lakes appear where once there was only sand, their surfaces alive with ripples of wind and lightning. It seems, perhaps, a blessing, a gift from the heavens to a land long starved. Yet blessings can shift, subtle as a shadow. The rains do not stop. Weeks pass, then months, and the air remains swollen with moisture. Plants spread quickly, seeds bursting in soils newly softened. Ferns unfurl, mosses creep, and strange forests begin to rise in places once thought barren. This sudden greening transforms landscapes into living experiments. Creatures adapted to aridity now face unfamiliar abundance. For some, it is opportunity. For others, doom. Picture the rhynchosaurs, squat herbivores with beaked mouths, once masters of dry floodplains. Their bodies, designed for scraping what little vegetation deserts allowed, now move through dense thickets where competitors multiply. Their beaks cannot adapt quickly enough. Their dominance begins to falter. Meanwhile, early dinosaurs, lighter, faster, opportunistic, slip easily into the new world of wet soils and tangled growth. They are small for now, but they are listening to the rhythm of change, and they are ready to dance to its beat. Still, the first rains are not uniform. Geological evidence suggests they arrived in pulses. Sediment layers show alternating bands of dry and wet, hinting at a climate swinging wildly between scarcity and abundance. Imagine entire generations of creatures born into drought, only for their descendants to drown in floods. Evolution itself stumbles, forced to adapt in rapid, disorienting steps. Odd fragments of fossil evidence point to extremes. In some places, spores of ferns spike dramatically, suggesting sudden blooms after fire or flood, pioneers rising after devastation. In others, layers rich in charcoal hint at wildfires ignited by lightning, even as rains fell. Was the earth caught in contradiction, burning and drowning at once? The record is incomplete, leaving scientists to argue. Were these first rains gentle harbingers or violent intrusions? Did they spread evenly across Pangaea or strike in uneven bursts, carving patterns of chaos across the supercontinent? The truth may be forever hidden, washed away by time. Yet one fact is clear: the skies had shifted. What had once been silence now carried constant thunder. For animals and plants, survival was no longer about enduring absence, but navigating excess. Drought had defined them for millions of years. Now they faced the strange weight of abundance. And abundance, unchecked, can be as deadly as scarcity. Consider the amphibians. For so long they clung to shrinking pools, their bodies tied to water. At first, the rain seemed salvation. Ponds spread into marshes, marshes into swamps. But soon, the wetlands grew too unstable. Floods tore through breeding grounds, currents swept eggs away, and stagnant pools bred disease. What had been lifelines became traps. Fossil counts suggest amphibian diversity plunged during this time, unable to cope with the volatility of endless storms. Meanwhile, the very air was changing. Rain does more than water the ground, it transforms the sky. Torrents pulled carbon from the atmosphere, mixing it with soils, altering chemical cycles. Some regions cooled, others warmed, depending on shifting balances of gas and ocean. It was a world where climate itself seemed to experiment, changing gears too quickly for stability. Creatures adapted to predictable drought now found themselves chasing a rhythm too erratic to follow. And for humans, far in the future, these first raindrops are preserved not in memory, but in stone. Layers of sediment capture sudden shifts in mineral composition. Iron leached from rocks, washed into rivers, settling into beds of red clay. Each layer is a page in a history book written without words, telling us of a sky learning to weep. In some layers, pollen and spores appear in strange abundance, signatures of ecosystems resetting themselves after floods. These silent witnesses remind us that the first rains were not myth, but memory, carved into earth itself. Now, pause for a moment and listen, not with ears, but with imagination. Hear the patter of rain on leaves that never knew such touch before. Hear the roar of rivers carving valleys where deserts once stretched. Hear the creatures stirring in confusion, their instincts caught between ancient drought and new deluge. The world is shifting, not gently, but with the subtle cruelty of inevitability. No single creature can sense the scale. No reptile, no fern, no insect can understand that what begins with these first drops will not end for 2 million years. But we can. We, looking back through stone and time, know that this is no passing storm. It is the overture of the Carnian pluvial event, the beginning of rain without end. And so, as the first storms rumble across the Triassic horizon, Earth takes its first breath of transformation. The desert is tremble, the rivers rise, and life itself feels the first pull of destiny. What was silence becomes song, what was dry becomes drowned, and what was steady begins to unravel. The sky has broken its vow of stillness, and from this moment forward, the world will never again be the same. The first rains may have seemed miraculous, pools where once there was dust, rivers bursting through old scars in the land, but miracles, when unceasing, take on the shape of dread. Imagine that the skies above you never clear, that the clouds, once rare visitors, grow heavy and permanent, hanging low like a dark canopy stretched across the earth. Lightning tears across them not in moments, but in constant flickers, an endless strobe. Thunder ceases to be an event. It becomes the background hum of existence. This is what followed. The rains did not pass. They deepened. They became the very heartbeat of the world. Day and night blurred together, each hour marked only by intensity, by the pounding of drops on leaves, on stone, on the rising floods that carved their way across Pangaea's deserts. To stand in this world was to live beneath a waterfall stretched across continents. Every horizon shimmered with curtains of water, every valley filled with torrents, The sky itself seemed to dissolve, falling in unbroken sheets. In such a world, silence was lost. The soundscape of the earth transformed, rain hammering on canopy and clay, rivers swelling with rage, trees groaning beneath constant weight, winds whipping water sideways so that storms became walls of moving glass. To sleep, if sleep was possible, was to dream to the rhythm of thunder. Creatures accustomed to brittle quiet now moved in an endless orchestra of noise. And with sound came transformation. Desert dunes that once shifted lazily under sun collapsed into mud. Dust plains hardened into lakes. Forests spread, dense and sudden, across regions that had never known such green. But these forests were unstable. They rose quickly, then drowned just as fast. Swamps replaced woodlands, marshes expanded, rivers braided across floodplains like restless serpents. What was dry became wet, what was solid became fluid, and the land itself seemed to melt into flux. This was not ordinary rain, not even a long season. It was a planetary regime. Sediment records tell us that this climate persisted for nearly 2 million years, broken into pulses of intensity. The Earth was trapped in a loop. Volcanic gases thickening the air with carbon dioxide and methane, oceans warming, evaporation increasing, and rain feeding back into itself like a drumbeat that would not falter. The hydrological cycle became overclocked, hyperactive, relentless. To live in this storm world was to adapt or vanish. Amphibians, once celebrants of water, found their very element turned against them. Pools that had offered refuge became volatile, surging and vanishing, too unstable to sustain eggs or tadpoles. Disease spread in stagnant floodwaters. Many amphibian lineages, ancient survivors of earlier extinctions, dwindled into shadows of their former selves. Other creatures fared no better. The great crocodile-like archosaurs that once dominated floodplains were heavy-bodied, ill-suited for a world of endless mud. Their strong jaws and armored hides became burdens as their territories drowned. Fossils suggest their diversity waned. The mighty rhynchosaurs, those beaked herbivores that once thrived in dry plains, lost their foothold entirely. They had been rulers. Now they vanished into extinction. And yet, as in all upheaval, others rose. Small, lightly built dinosaurs, once peripheral figures in Triassic life, found themselves strangely suited to this world. Their air sacs, adaptations that lightened their skeletons and enhanced breathing, gave them an edge in humid, oxygen-shifting atmospheres. Their agility allowed them to traverse unstable landscapes, to move between islands of survival in the new wet mosaic. It was not dominance yet, but it was advantage, a whisper of the power they would one day wield. The storms did more than drown, they carved. Rivers tore through soils, pulling nutrients into seas. Ocean chemistry shifted as runoff poured endlessly into basins. Blooms of plankton flourished, only to collapse into anoxic voids. The cycle of abundance and suffocation repeated, mirrored in both land and sea, and always, above it all, the rain fell, as though the planet itself wept without end. Imagine the sensory world of these storms, the air heavy and wet, every breath thick with vapor, the ground yielding underfoot, mud swallowing steps whole, vision blurred not by distance but by walls of falling water, horizons erased, landscapes hidden in curtains of storm. Even fire, the oldest companion of life on land, struggled to survive. Lightning still split the skies, igniting forests, but flames sputtered in saturated wood, smoke smothered by downpour. To live here was to live in water's dominion. And yet, within this chaos, beauty bloomed. ferns spread in carpets across floodplains, their spores recorded in massive spikes in the fossil record, proof of their sudden dominion. Strange amphibious reptiles lurked in swamps that stretched farther than eyes could see. Insects hummed in damp forests, wings glistening with droplets. Even as death stalked many, creation moved in parallel, seeding new patterns, new opportunities. Catastrophe and Genesis shared the same rhythm, as they often do. Scientists debate the exact character of these rains. Were they uniformly torrential, or did they surge in cycles, years of relative calm followed by decades of catastrophic downpour? Oxygen isotope records suggest oscillations, patterns like the breath of storms across millennia. Perhaps there were moments when skies cleared slightly, when Kriatu Res felt hope, only for darkness to close in again. This uncertainty remains, a question carved into stone, but not yet fully answered. Odd clues emerge. In certain regions, deposits show layers of dried mud cracked beneath new flood sediments. Could it be that droughts briefly returned, teasing with old familiarity, only to be erased again by storms? If so, imagine the cruelty. Creatures adapting to rain, then suddenly starved of it, then drowned once more. Not one rhythm, but many, layered upon each other, keeping the world perpetually off balance. And through it all, Earth's sky became both giver and destroyer. The rains fed growth, filled rivers, birthed forests, but they also drowned, eroded, suffocated. What once had been desert stability became storm volatility. The planet had shifted regimes, and there would be no return. Pause and feel it. Hear the ceaseless thunder, the crack of lightning over saturated plains. Smell the damp earth, forever wet, rich with rot and renewal. Taste the air, metallic with ozone, sharp with minerals leached from endless runoff. Look across the land and see rivers where deserts once stretched, lakes where sand seas once roamed, forests drowning under their own weight. This is the world remade by storm, a world where rain no longer falls as event, but exists as condition. For 2 million years, the planet would breathe water, exhale rivers, dream only in floods. And beneath it all, deep in Earth's crust, the true engine of this transformation rumbled. Volcanoes stirred, magma surged, gases filled the skies. The rains above were only one half of the story. The other half burned beneath, waiting to erupt. Beneath the curtain of endless storms, the Earth's crust trembled with a deeper fury. For while the rains soaked the land, another force was at work, an inferno rising from below, ancient, unstoppable. The Central Atlantic Magmatic Province, or camp, was awakening. Imagine fissures so vast they stretched for hundreds of kilometers, rifts splitting Pangaea's bones open, spewing fountains of lava that lit the storm-dark skies with crimson fire. This was no local eruption, no fleeting burst of magma. This was volcanism on a continental scale, a convulsion of the planet itself. Over hundreds of thousands of years, lava poured out in sheets, covering millions of square kilometers, enough to bury regions the size of modern Europe beneath molten stone. It was a violence so sustained, so relentless, that it reshaped not only the land, but the very atmosphere that cloaked the world. Picture the scene: rain lashing down in unbroken torrents, lightning webbing across clouds, and in the distance, horizons glowing with rivers of lava. Fire and water, normally enemies, collided in strange harmony. Rain hissed on volcanic rock, creating clouds of steam that joined the storm above. Ash rose into the sky, mixing with thunderclouds until lightning flashed, not just from weather, but from eruptions themselves. It was as though Earth's surface and sky had entered into a dialogue of chaos, lava answering rain, storm answering fire. With every eruption, gases surged upward: carbon dioxide, sulfur dioxide, methane. These invisible vapors became the architects of climate, painting the planet with alternating masks of warmth and cold. Sulfur aerosols spread through the stratosphere, reflecting sunlight, dimming skies, cooling regions into temporary winters. But then carbon dioxide and methane overwhelmed them, trapping heat, intensifying evaporation, feeding back into storms. This push and pull, cooling shadow, suffocating warmth, was the heartbeat of the Carnian pluvial event. Scientists call it climate whiplash. The world swung violently between states, ecosystems never allowed to settle. Creatures that could endure drought were drowned. Creatures that thrived in abundance were starved when cooling came. It was a rhythm of instability dictated by the breath of volcanoes. Fossil records reveal bursts of extinction, followed by odd recoveries, echoing these swings. Entire lineages rose and fell within geological moments, lives tied to the volatile pulse of magma below. The rains weep, the volcanoes burn, two halves of one story. For the volcanism did not simply ignite storms by accident, it drove them. Gases filled the atmosphere, warming oceans, driving evaporation, fueling the cycle of rain. Without eruptions, no endless deluge. Without storms, no amplification of volcanic scars. They were partners in destruction, entwined, feeding each other in a feedback loop that lasted for 2 million years. Now, lean closer. Imagine breathing that air, heavy, thick with carbon dioxide, sharp with sulfur, carrying the acrid sting of acid. Rain fell not as pure water, but as dilute acid, etching stone, leaching soils, stinging the skin of any creature exposed too long. Plants struggled against this chemical assault, their leaves blistered, their roots forced to adapt to soils stripped of nutrients. Forests rose in haste, only to wither, replaced by new assemblages of flora that could endure the poisoned sky. Stranger still, the record whispers of methane clathrates, frozen reservoirs of carbon hidden in sediments, destabilized by warming seas. If released, they would have spilled methane into the atmosphere, amplifying heat many times over. Was this part of the cascade? Did Earth open not just its volcanic lungs, but its buried reserves? The debate continues, a riddle carved into stone, unresolved yet essential. And while the planet raged, the geography itself began to change. Pangaea, though immense, was not eternal. The rifts, birthed by Camp, were the first tears that would, millions of years later, split continents into the arrangement we recognize today. The Atlantic Ocean was still unborn, but its womb was stirring. The rains above, the fire below, both were midwives of continents, reshaping the very map of Earth. Imagine yourself as a witness. You stand on sodden ground, soaked by endless rain. Ahead, fissures rip open, glowing with fire that boils the storm water pouring in. Rivers of lava stretch toward the horizon, cooling into black plains that steam beneath downpours. The sky is a battlefield, storms colliding with plumes of ash, lightning lacing clouds stained red by volcanic light. The air shakes with thunder and eruption alike, indistinguishable, merging into one deafening symphony. In this chaos, life faltered. Coral reefs, already stressed by runoff, collapsed entirely under acidified seas. On land, herbivores starved as plants shifted and failed. Predators, dependent on prey, dwindled in turn. Extinction spread like ripples from a stone dropped in water, waves radiating through ecosystems. Yet at the edges of collapse, resilience whispered. Some plants adapted, developing strategies to endure nutrient-poor soils. Some reptiles adjusted, shifting diets, moving into new habitats carved by storms. And dinosaurs, those small and agile survivors, continued to find footholds in niches abandoned by others. odd clues remain of these fiery centuries. Ancient lava flows preserved across modern Africa, Europe, and the Americas are identical, proof of the scale of eruption. Gas bubbles trapped in basalt whisper the chemistry of ancient air. Charcoal layers reveal forests that burned despite the rains, ignited by volcanic lightning. Even isotopic signatures in marine sediments record the shifting breath of carbon, pulsing in time with eruptions. The evidence paints a picture not of singular events, but of a prolonged planetary fever. And yet, mysteries endure. Did the rains begin first, primed by gradual warming, with volcanism only amplifying them? Or was it the eruptions themselves that triggered the very first storms? Some argue that tectonic movements subtly shifted wind and ocean currents, setting the stage before fire and water collided. Others insist the volcanoes were the root cause. The truth may be layered, like the strata of stone that preserve their memory, a web of triggers woven together. For the creatures who lived through it, such debates did not matter. For them, reality was simple: skies that never cleared, air that burned to breathe, ground that quaked with fire. This was their world, and it reshaped them in ways subtle and profound. The weak fell, the adaptable endured, and those who could seize opportunity began to ascend. Pause here, close your eyes. Hear the dual chorus of storm and eruption, the hiss of rain on lava, the crack of lightning mirrored by volcanic blast. See the horizon glowing red beneath black clouds, rivers of molten stone braided with rivers of floodwater. Feel the heat of magma rising from beneath your feet, even as cold rain lashes your face. This was no ordinary age. This was Earth remaking itself through contradiction, water and fire, creation and destruction, destruction and creation. The rains had become endless, the volcanoes unrelenting. Together they forged not only extinction, but the raw materials of a new world. And as they raged, oceans too began to change, becoming theaters of upheaval as profound as the land above. For when rivers of storm water poured endlessly into seas, life beneath the waves found itself caught in another form of catastrophe. Beneath the storm-lashed skies, while lava scarred the land and acid rain carved at stone, another transformation was underway, one hidden from the eyes of land-bound creatures, but no less catastrophic. The oceans, those ancient cradles of life, were unraveling. Imagine the rains, relentless and unending, cascading from the heavens for centuries, for millennia. Rivers swollen beyond measure tore soil from mountainsides, carrying sediments and nutrients into the seas. What began as a trickle became a torrent, a vast conveyor of minerals and organic matter rushing into coastal waters. For a brief time, the oceans flourished. Algae and plankton, fed by this banquet of nutrients, bloomed in staggering abundance, their populations surging until the very surface of the seas glowed green with life. But excess in nature is a double-edged sword. As the blooms collapsed, their remains drifted downward, a slow rain of decay that fed bacteria. These microbial armies consumed oxygen as they devoured the organic feast, and the seas began to suffocate. Waters that had once teemed with vitality grew stagnant, starved of oxygen. Coral reefs, those architects of biodiversity, collapsed as acidified waters and suffocating anoxia spread. Fish and invertebrates perished en masse, leaving behind empty shells and ghost reefs where once there had been bustling ecosystems. Geological evidence speaks clearly of this devastation. Black shales rich with organic carbon mark layers of time when oceans turned hostile, storing in stone the memory of suffocated seas. In these layers, the absence of reef-building organisms tells its own story. What had been vibrant underwater cities dissolved into silence. But there was more than oxygen loss. As volcanic gases filled the skies, Carbon dioxide dissolved into the rain and oceans, turning waters corrosive. Acidification weakened shells, disrupted metabolic processes, and stripped reefs of their builders. Imagine the sea itself becoming a solvent, eroding the very skeletons of creatures that relied on calcium carbonate for structure. The waters became both womb and grave, and then, darker still, hydrogen sulfide. In times of deep anoxia, when oxygen is stripped away, certain bacteria thrive by producing this deadly gas. Some scientists argue that during the worst pulses of the Carnian pluvial event, hydrogen sulfide built up in oceans and even seeped into the atmosphere. If true, it would have created toxic zones near coasts, suffocating creatures both in water and on land. Though evidence remains debated, whispers of this possibility linger in chemical signatures preserved in stone, a reminder that Earth's seas once flirted with poison. Life in the oceans was cornered. Many groups collapsed, their diversity shrinking to shadows of what once was. Reef systems, which had dominated the Triassic seas, vanished for millions of years, leaving behind only fragments. Large predators lost their prey and dwindled in turn. Entire food webs unraveled. Yet, paradoxically, in this collapse lay opportunity. New groups of plankton began to rise, resilient to fluctuations. Mollusks found niches in disturbed ecosystems. Marine reptiles, though challenged, adapted to shifting prey. The ocean, though wounded, did not fall silent. It transformed. Extinction cleared the stage, and new actors emerged. Picture the seascape, a world of murky waters, blooms staining the surface, dead zones lurking beneath. The reefs, once bright with life, are dark skeletons cloaked in algae. Fish scatter in reduced numbers, while strange survivors, ammonites with coiled shells, ichthyosaurs with sleek forms, navigate the shifting seascape. Above, storms rage endlessly, their downpours feeding the chaos below. The ocean breathes shallowly, its pulse weak, its lungs compressed by suffocation. The scale of this turmoil was not local. Sediment cores from Europe, China, North and South America all tell the same tale. Oxygen plummeting, ecosystems collapsing, seas becoming inhospitable. This was a global transformation, a reshaping of oceans that mirrored the chaos on land. The entire biosphere was caught in a single web of storm and suffocation. Odd fragments of evidence add mystery. In some regions, bursts of carbonate deposition suggest temporary rebounds of reef life, as though ecosystems tried to rebuild themselves in brief intervals of relief. But then, silence again. Was the ocean caught in cycles, struggling to recover before being crushed anew? Scientists continue to debate. The layers of stone hold both the scars of collapse and the whispers of resilience, an incomplete narrative waiting to be fully read. And through it all, storms fed the seas. Rainfall carved nutrients from volcanic rock, accelerated chemical weathering, and flushed minerals into water. Some argue that these processes drew carbon from the atmosphere, cooling the planet briefly, only for volcanism to inject more gases and restart the cycle. In this way, oceans became not just victims, but players in the drama, a planetary system swinging wildly between states, each feedback amplifying the chaos. Close your eyes, drift down into those Triassic seas. The light dims as you descend, filtered through murky blooms. Shapes move sluggishly, struggling in oxygen-starved waters. The silence is oppressive, broken only by faint echoes of distant thunder rolling across the surface above. The water is heavy, dense with decay, tasting faintly of acid and sulfur. You can almost feel the suffocation pressing against your chest, a reminder of the fragility of life when oxygen fails. And yet, even here, even now, beauty survives. Strange new plankton shimmer, ammonites spiral gracefully. Marine reptiles carve their paths with precision. In collapse lies invention. In death lies rebirth. The oceans, though torn apart, were being rewritten. Scientists remind us that without these upheavals, later marine ecosystems, including those that supported the rise of modern fish and corals, might never have taken root. The loss of one world became the foundation of another. The storms, the runoff, the suffocation, they were architects as much as executioners. Debates endure. Did hydrogen sulfide truly breach the seas to poison the air? Were these oceanic changes steady across 2 million years, or pulsed-like? The reigns above, cycles of collapse and partial recovery. How far did reefs truly vanish, and how quickly could they rebound? These are questions still being pursued in labs and field sites. The ocean's ancient memory pieced together from fragments of shale and fossil. But for the creatures of the Triassic, no such debates mattered. Their world had shifted. Seas once stable became volatile. Oxygen once plentiful became scarce. Habitats once vibrant dissolved into graveyards. And still, above them, the rains fell, feeding rivers that fed the seas, while volcanoes poured gases that thickened the air and warmed the water. The oceans, like the land, had entered the crucible, and as seas suffocated and forests withered, the land itself grew more toxic, poisoned by the same rains that sculpted rivers. For the waters falling from the sky carried more than life, they carried death. The rains that fell were not gentle. They did not cleanse or nourish as they do in springtime today. They were corrosive, transformed by the breath of volcanoes into an alchemy of ruin. Every drop that fell carried whispers of sulfur and carbon, mingling with water to form acid. Imagine rain that stung the skin, that stripped leaves of their waxy armor, that etched the very bones of the land. This was no blessing. This was the sky, bleeding chemistry onto earth. Acid rain poured for centuries. With every downpour, soils leached away their precious nutrients. Minerals vital to life dissolved, washed into rivers, carried to seas, already choking with excess. Plants, once quick to rise in the new wet climate, began to wither. Leaves turned brittle. Roots struggled to grip poisoned ground, and forests collapsed in cycles of sudden growth and sudden death. Where once lush carpets of ferns spread after fires, their spores saturating the fossil record, now bare patches scarred the landscape as the earth itself grew hostile. Picture the land. Hillsides stripped of vegetation bleed mud into swollen rivers, valleys fill with marshes, acidic pools steaming beneath endless rainfall. Tree trunks rot at their bases, toppled into streams that carry them away like corpses. Even the air tastes sharp, laced with the acrid tang of sulfur. It is a world of damp and corrosion, where life must constantly rebuild itself on shifting ground. Animals too suffered. Herbivores that grazed on foliage found their diets poisoned. Some plants developed chemical defenses. Others simply perished, leaving grazers starved. Fossil evidence suggests dramatic turnovers. Dominant groups like rhynchosaurs dwindled and vanished, their specialized diets failing them in this new chemistry. Predators followed, deprived of prey. Ecosystems unraveled, not just from drowning and storm, but from the slow, insidious touch of poisoned rain. Yet even in this devastation, some found footholds. Small, agile reptiles adapted, shifting diets and exploiting whatever plants or insects survived. Early dinosaurs, with their efficient lungs and nimble builds, maneuvered through landscapes where larger, heavier creatures struggled. Where others sank in mud, they darted across. Where others starved, they scavenged. The poisoned earth did not spare them, but it favored those who could bend without breaking. Odd details remain preserved in stone. Layers of soil show signs of chemical weathering far beyond ordinary. Sediments reveal spikes in aluminum and iron, minerals leached by acid and redeposited downstream. Charcoal fragments testify to forests that briefly burned between deluges, their regrowth marked by fern spores that surged only to vanish again. Each layer is a pulse of struggle, written into Earth's archive. Scientists still debate the intensity of this acid assault. Were the rains uniformly corrosive, or did they arrive in pulses tied to volcanic outbursts? Some evidence suggests alternating rhythms, periods of extreme acidity followed by intervals of relative reprieve. Perhaps forests had moments of recovery, only to be stripped again. The truth remains uncertain, the details lost to the passing of millions of years. But the overall story is clear. Chemistry had become weaponized. Now imagine walking across such land. Your feet sink into mud that bubbles faintly with chemical reaction. Streams run cloudy, their waters metallic, carrying a taste that burns on the tongue. The smell of rot and sulfur clings to every breath. Plants look strange, leaves curled, bark scarred. Insects flit in diminished numbers, some thriving in the wet, others gone entirely. The world feels unstable, shifting beneath your every step, as though Earth itself resists your presence. And yet, paradoxically, these poisons opened new doors. By leaching soils, the rains forced ecosystems to reinvent themselves. Some plants evolved deeper roots, better able to access hidden reserves. Others developed chemical resistance, adaptations that would shape lineages for millions of years. Insects co-evolved, adjusting diets and life cycles to match new flora. What was destruction for many became opportunity for a few. Out of toxic mud, new ecosystems began to whisper into existence. The record shows dramatic turnovers in vegetation. Conifers, once steady rulers, faltered, while new plant groups surged. Ferns, with their resilience, often took over scarred landscapes, only to be displaced again. This churn of flora reset the stage, shuffling the deck of evolution. Creatures adapted to old diets suffered. Those willing to change endured. Consider the amphibians. For ages, they had been masters of wet places, tied to water, but thriving wherever pools persisted. Now, their skin, permeable and vulnerable, made them victims of chemical rain. Eggs dissolved in acidic puddles. Populations collapsed. Some clung on in pockets of stability, but their reign was ending. Meanwhile, archosaurs with crocodile-like forms, once dominant on floodplains, and themselves weakened. Their heavy bodies were ill-suited to swamps of mud. Their prey diminished, their habitats shrank, and acid-borne diseases spread. They dwindled step by step, leaving room for others to rise. And through this poison, the small dinosaurs advanced. Their lungs, bird-like in design, may have filtered air more efficiently, handling fluctuations in oxygen and acidity better than others. Their lighter frames allowed them to move through bogs. Their varied diets gave them options in unstable ecosystems. They did not yet rule, but they endured. And endurance is the seed of dominance. Pause here and imagine the sensory weight of this poisoned earth. Hear the rain hissing as it strikes bare rock, fizzing faintly where it meets soils stripped to minerals. Smell the acrid air, taste the metallic tang on your tongue, feel the ground yielding beneath your feet, soft and unstable, as though it too is weary. This is no ordinary world. This is Earth experimenting, pushing boundaries, rewriting the rules of survival. Scientists today still search for clarity. Was the acidification primarily volcanic, or amplified by feedbacks of decaying forests and seas? How severe was the chemical stripping of soils? Could such processes have been localized, or were they global, draping the whole planet in corrosive shrouds? These questions remain open, their answers locked in incomplete records. What we know is enough to inspire awe and unease. The land itself had turned against its inhabitants. Yet this poisoned earth was not the end. It was the crucible. Just as metals are forged in fire, life was being reforged in acid and storm. The lineages that survived would carry new adaptations, innovations that would echo into the age of dinosaurs and beyond. Out of dissolution came design. Out of decay came resilience. And so, as the rains etched stone and stripped forests, as soil else bled their minerals into rivers, the earth prepared for the next turn of its cycle. For when ecosystems falter, they do not vanish entirely. They reorganize. They seek new balances. And in that reorganization lies the future. The earth, poisoned and stripped, was readying itself for the rise of new rulers. But first, it would cull the old. The rains did not fall evenly upon all lives. Some found their worlds collapsing beneath the weight of storm and acid, while others, quietly, almost invisibly, discovered opportunity hidden in the chaos. Every extinction is also a rebalancing, and in the late Triassic, as the Carnian pluvial event stretched on, the ledger of existence was rewritten line by line, name by name. Begin with those who lost. Amphibians had once been resilient survivors. For over 200 million years, they had endured upheavals and thrived in swamps and streams. But in this new world of poisoned waters and erratic floods, their very strengths betrayed them. Their porous skin, which allowed them to breathe through moisture, became a liability when rainfall burned with acid. Eggs, once cradled in shallow pools, dissolved in corrosive puddles. Tadpoles were swept away by sudden torrents or suffocated in stagnant, oxygen-poor waters. Their chorus, which had once filled the nights of Triassic floodplains, dwindled to silence. Next came the rhynchosaurs. Strange, beaked herbivores with squat bodies and powerful jaws, they had thrived in arid floodplains, scraping roots and stems from sparse vegetation. In the new wet world, their specialization betrayed them. Plants shifted. Ferns and fast-growing opportunists took over, but the rhynchosaurs could not adapt quickly enough to these diets. Their once dominant herds dwindled, their footprints vanishing from sediments that had recorded them for millions of years. By the close of the deluge, they were gone, their lineage erased. And the crocodile-like archosaurs, heavy-bodied, armored, rulers of riverbanks, found themselves undone by mud and flood. Built for strength and ambush, they were ill, suited to unstable floodplains and shifting swamps. Prey grew scarce. Territories vanished beneath waters, and competition pressed hard. Their ranks thinned, leaving behind only a few survivors who would one day give rise to the crocodiles we know today. But their dominance, their Triassic empire, ended here. Now turn to those who won. Small, lightly built dinosaurs had existed in the margins before the deluge. They were not yet rulers, overshadowed by larger reptiles and amphibians, but their physiology gave them hidden advantages. Their bones were hollow, light for movement across treacherous ground. Their lungs, with air sacs more efficient than those of their rivals, allowed them to breathe in humid, oxygen-fluctuating atmospheres. Their agility let them exploit new niches as forests shifted and swamps expanded. Where others starved, they scavenged. Where others drowned, they darted. They were not yet giants. They were fleet-footed hunters and nimble foragers. But as the storms culled the old rulers, dinosaurs found space to grow. They moved into abandoned niches, tested new diets, expanded into new territories. Their resilience became momentum, and momentum became ascendancy. Without the deluge, their story might have been a footnote. With it, they began the slow climb toward domination. Other winners were less obvious. Ferns, humble plants, thrived in disturbance. Every time a forest collapsed under flood or acid rain, ferns surged into the gaps, their spores filling the air. Fossil records show enormous spikes in fern spores during this period, evidence of landscapes carpeted in green after devastation. They were not permanent rulers, but they were survivors, opportunists, whose resilience ensured life always returned after loss. Even in the oceans, some found advantage. While reefs collapsed, planktonic groups diversified. Their rise reshaped marine ecosystems, laying the groundwork for future oceanic food webs. Mollusks, too, adapted to shifting chemistry, seizing niches left empty by other shelled organisms. The oceans, though suffocated, never fully surrendered. They restructured. Strangely, the deluge may also have opened doors for mammals, tiny, shrew-like creatures hiding in shadows. They were not yet dominant, but their small size, nocturnal habits, and flexible diets may have allowed them to endure the volatility. Fossil hints suggest they persisted quietly, laying evolutionary groundwork that would matter far later, long after the age of dinosaurs. The fossil record captures this balance sheet with brutal clarity. Diversity of amphibians plunges, rhynchosaurs vanish, crocodile kin diminish, dinosaurs expand, fern spores spike, reef builders collapse, plankton shift. Each layer of sediment is a tally of gain and loss, a record of winners written in spores and bones, and losers written in absence. Yet debates linger. Some scientists argue that not all rhynchosaurs perished instantly, that they lingered in pockets, fading slowly. Others suggest crocodile kin were more resilient than once thought, surviving in regions less affected by flooding. The details remain contested, the fossil record incomplete, but the overall pattern is unshakable. The deluge reordered life's hierarchy. Pause and imagine this reshuffling. Herds that once darkened horizons vanish, leaving plains strangely empty. Amphibian calls grow rare, nights falling silent. Predators, hungry, search but find less. And in the gaps, small dinosaurs move, tentative at first, then bold. Ferns spread in green waves where forests collapse. Insects buzz across new growth, feeding small reptiles that in turn feed predators. Life does not stop, it reorganizes. This is the paradox of extinction events. To those who live through them, they are apocalypse. To those who follow, they are opportunity. The losers vanish into memory, the winners define the future. In the Triassic, the rains did not simply drown or poison, it cleared space. Into that space, dinosaurs stepped, their story beginning in earnest. Imagine standing on a storm-lashed plain at the edge of a flooded forest. You see corpses of rhynchosaurs, great beaked bodies rotting in mud. You see archosaurs sinking into swamps, their heavy frames trapped. You hear silence where amphibians once sang. And then, in the undergrowth, you glimpse a figure, small, nimble, eyes bright, moving lightly across sodden ground. A dinosaur, a survivor, a herald of what is to come. The deluge was cruel, it was merciless, but it was also a midwife. Out of its violence came a new world, a new order, winners and losers, endings and beginnings. The rains chose with no compassion, no intention. They fell blindly, yet their falling sculpted destiny. And as the world reordered itself, as some lineages vanished and others rose, the story of this transformation was being written into stone, into spores, into isotopes, evidence, waiting for future eyes to read. The rains have ceased for us, millions of years later, yet their echoes remain, not in memory, for no human eye ever saw them, but in stone. The earth itself is a library, and each layer of sediment, each shift in mineral, Each fossilized spore is a page written in the language of geology. To reconstruct the story of 2 million years of storms, scientists do not look to myth or rumor. They read the rocks. Begin with color. Across what were once floodplains, the sediments redden. Iron within the soils oxidized under torrents of water, staining clays a deep, rusty hue. These red beds stretch across continents, from Europe to China to the Americas, a fingerprint of altered climate. Their chemistry reveals intense weathering, rain leaching minerals, stripping soils, transforming landscapes. Each layer is a testimony that rain not only fell, but endured, sculpting Earth into new forms. Then come the spores. In strata dated to the Carnian pluvial event, ferns leave their unmistakable mark. Their spores surge in sudden abundance, a signal of landscapes disturbed and reset. Ferns, ever the opportunists, colonized bare ground left by flood or fire. They covered scars with green, only to be displaced again when forests rose, only to return when the storm struck once more. The fern spike is one of the clearest indicators of environmental upheaval, an ecological signature etched into stone. Pollen tells another story. The grains of conifers and seed ferns decline sharply during this period, evidence of forests faltering. Plants that once dominated drier Triassic climates lost their footing under endless rain and acid soil. Their absence, paired with the fern surge, records not just collapse, but transition. Entire ecosystems turned over, their memory pressed into microscopic grains of pollen fossilized in mudstone. And in the oceans, isotopes whisper their tale. Oxygen isotope ratios in marine sediments shift dramatically during the Carnian pluvial event. These changes speak of fluctuating temperatures, of cycles of rainfall and drought, of seas destabilized by carbon injection and volcanic upheaval. The very atoms of ancient shells hold records of climate oscillations, their ratios a diary of a planet gasping between states. Strontium isotopes, too, carried by rivers into oceans, show spikes during this time, proof of accelerated weathering as volcanic landscapes were stripped by rain. The chemistry of stone becomes a chronicle of storm. Fossils add their voices. In strata from this age, entire assemblages change. Amphibians vanish from records, rhynchosaurs disappear, archosaurs dwindle, dinosaurs multiply, their footprints preserved in trackways etched into once soft mud. What had been rare becomes common. In one layer, the world is ruled by one caste of creatures. In the next, by another. The rocks themselves preserve the changing script of life. Charcoal. Layers, thin but global, tell of wildfires ignited by volcanic lightning, even under skies thick with rain. Burned forests, fossilized in blackened fragments, record moments when fire and storm collided. Above these charcoal bands, fern spores surge again, as if rehearsing the endless cycle: fire, fern, forest, flood. All these signs converge. Separate continents, now scattered by plate tectonics, hold the same signals. Reddened clays in Europe, fern surges in South America, isotope shifts in Chinese sediments, charcoal in North America. Together, they weave a single story. This was no local catastrophe. It was global. The deluge reached across the breadth of Pangaea, binding distant lands into one shared narrative. And yet, mysteries persist. The stone does not speak in full sentences. Its pages are torn, smudged, incomplete. Scientists debate the tempo of the storms. Were they steady across 2 million years or pulsed in violent bursts, each tied to volcanic outpourings? Oxygen isotopes suggest cycles, but how regular, how synchronized, remains uncertain. Did acid rain scorch every forest, or were some refuges spared? Did reefs collapse universally, or did isolated havens endure? The rocks hint, but they do not confess. Odd fragments complicate the tale. In certain deposits, pockets of plant diversity seem to persist, suggesting microclimates that sheltered life. In others, temporary reef growth appears, only to collapse again. These fragments remind us that even in catastrophe, Earth is patchwork. Destruction is rarely uniform. Life clings in corners, hidden sanctuaries that seed recovery when storms relent. Still, the broad picture is undeniable. Across continents, across ecosystems, across land and sea alike, the late Triassic wears the scars of endless rain. The signs in stone are concordant, like voices in a choir, harmonizing across time. They speak of a plan, et convulsed, of climate destabilized, of life reordered. Imagine walking with a geologist in a modern desert canyon. They point to a stratum of red shale, to a layer rich in spores, to a band of dark shale dense with organic carbon. To the untrained eye, these are mere colors, mere textures, but to the trained, they are words, lines in an epic poem written by Earth itself. Here, they would say, is when the rains began. Here, where the ferns surged. Here, where reefs died. Here, where the dinosaurs stepped into the light. The rocks are patient. They have waited millions of years for eyes to read them. They do not embellish, but neither do they tell everything. Their record is precise but partial. They give us certainty and mystery in equal measure. We know the rains lasted nearly 2 million years. We know volcanism and climate feedback drove them. We know who fell and who rose, but the details, the rhythms, the pulses, the lived experience are lost, except in imagination. And imagination, guided by evidence, is where science and wonder meet. The stones give us fragments, but we supply the vision, the thunder that never ceased, the forests collapsing in waves, the oceans suffocating, the dinosaurs rising. The rocks whisper, and we lean close to listen, to translate the language of minerals into the story of storms. Close your eyes now and picture those layers. Each one is a page, each mineral grain a word, each fossil a phrase. Together they compose a book 230 million years old, a chronicle of Earth remaking itself, a book that ends with silence, but between its lines, you can still hear the patter of rain. For 2 million years, the skies fell, and though the rains are gone, their memory endures, written forever in stone. When the last echoes of thunder softened and the storms began to lose their grip, the earth stood wounded. Forests had been drowned and burned. Deserts had become marshes. Oceans, once clear and rich with coral gardens, were left murky, starved of oxygen and stripped of reefs. Entire lineages had vanished, swept away by 2 million years of rain. But extinction is never a final silence. It is always followed by a whisper, a tentative return of life, a rewoven web spun out of what remains. Imagine standing on land that has just emerged from flood. Mud stretches for miles, still glistening under a gray sky. Pools dot the surface, steaming faintly with acid residue. Fallen trees lie like corpses, bark softened, roots exposed. And yet, from the soil, something green pushes upward. Ferns, always first to arrive, unfurl fronds in waves across the scarred ground. They do not ask permission. They simply rise, weaving a carpet of green across devastation. This was Earth's pattern: destruction, then renewal. With every collapse, with every flood or acid storm, new beginnings followed. The Carnian pluvial event did not erase life entirely. It reshaped it. Ecosystems that emerged after the deluge looked nothing like the ones that entered. The web of life was rewoven with different threads, different patterns, different architects. Forests shifted, Conifers, once weakened by rain and soil loss, began to adapt. Some species found ways to tolerate wetter soils. Others evolved strategies to resist acidity. Alongside them, cycads and ginkgos spread, filling niches left open. These forests were patchy, younger, less stable than before, but they were forests nonetheless. Insects followed, buzzing through new canopies, feeding on leaves, pollinating plants. Life stitched itself back together, one thread at a time. Dinosaurs, those small survivors of chaos, found themselves in landscapes reshaped to their advantage. With amphibians diminished, rhynchosaurs gone, and archosaur rivals weakened, they stepped into empty roles. Their light frames and efficient lungs gave them reach. They diversified, exploring new diets and habitats. Some grew larger, moving toward the forms that would one day dominate the Jurassic. What had been a background lineage became, slowly but surely, the center of the stage. Meanwhile, mammals, tiny, secretive, nocturnal, endured quietly in the shadows. Their small bodies, insectivorous diets, and burrowing habits shielded them from instability. While dinosaurs expanded, mammals persisted in obscurity, a secondary thread in the new web. But even these threads mattered. They would hold, waiting patiently for their own age. The oceans, too, began their slow recovery. Plankton, having survived collapse, diversified into new forms, reshaping marine food webs from the bottom up. Mollusks thrived in disturbed ecosystems, their shells recording the chemistry of waters still unsettled. Marine reptiles adapted to shifting prey, ichthyosaurs and nothosaurs, hunting in seas stripped of reefs. Though coral ecosystems had vanished, the oceans stitched themselves back together in simpler patterns, foundations for future complexity. It was not immediate. Recovery is never instant. It stretched over millions of years, a slow weaving of threads into fragile fabrics. For long spans, ecosystems remained unstable, prone to collapse at every shift. Yet the very fragility created dynamism. New species emerged at a faster pace, evolution quickened by instability. The world became an engine of experimentation. Odd clues in the fossil record capture this experimentation. Some sites show sudden bursts of diversity, new species appearing in clusters, as if evolution itself were accelerating. Others show ecosystems dominated briefly by strange, transient forms, plants or reptiles that flourished for a geological moment, then vanished, leaving only fossils as evidence of their fleeting reign. These experiments were nature's improvisations, attempts to fill empty roles in the web of life. And always, ferns returned. Every disturbance, every collapse was followed by another surge of res, carpeting the land with green resilience. The fern became a symbol of recovery, a constant reminder that life, however fragile, always seeks a foothold. Scientists today marvel at this pattern. Why does life rebound after catastrophe? Why does extinction clear space not just for survival, but for innovation? Some argue that instability itself drives creativity. In a stable world, niches are filled, competition is locked, and new forms struggle to find space. But in a shattered world, gaps open everywhere, opportunities multiply, and evolution takes bold leaps. The Carnian pluvial event may have been catastrophic, but it also unlocked possibilities that shaped the future. For without this reweaving, dinosaurs might never have risen. The rain cleared their rivals. The poisoned soils selected for resilience. The unstable forests favored mobility and adaptability. Dinosaurs did not merely survive, they thrived in the aftermath. The very conditions that seemed to spell ruin became the soil of their ascendancy. Imagine watching this transition unfold. At first, silence after storms, then carpets of ferns across mud, Then, small dinosaurs moving through new growth, scavenging and hunting. Then, forests returning in patches, insects buzzing, mammals skittering at night. Slowly, layer by layer, the world regains texture. It is not the same texture as before. It is new, woven from different threads, but no less alive. And this weaving was not confined to land. The oceans, too, found new balance. In place of lost reefs, simpler ecosystems took hold. Plankton diversified, seeding food chains that would support marine life for millions of years. Marine reptiles filled roles once held by fish, now diminished. Even in suffocated waters, niches reopened and life crept back in. But it was fragile. Each new web was thin, vulnerable to collapse. This fragility is written in the fossil record. Diversity rebounding, then stumbling, then rebounding again. It is the rhythm of a planet learning to breathe after suffocation. Scientists debate how long recovery truly took. Was it swift, a matter of a few million years? Or was it stretched, a slow healing that lingered deep into the Jurassic? Evidence points in different directions, depending on region and fossil group. The precise tempo remains unknown. What is certain is that recovery was uneven, patchwork, fragile. Yet fragility is not weakness. Fragility is sensitivity, and sensitivity drives change. In fragile ecosystems, evolution has room to experiment. The survivors of the Carnian pluvial event carried forward traits honed in adversity. Dinosaurs carried lungs adapted to chaotic atmospheres. Plants carried roots hardened against leached soils. Plankton carried resilience to fluctuating chemistry. These traits would define the next ages. Pause and imagine this Earth, a planet of renewal, but also of uncertainty. Forests green, but young and unstable. Dinosaurs moving with tentative confidence, not yet rulers but no longer shadows. Oceans filling with life, but still cloudy, still shallow in diversity. It is a world in flux, its web fragile but rewoven. And in this fragility lies the seed of future grandeur. For the dinosaurs will rise into titans. The forests will stabilize into lush ecosystems. The oceans will birth new reefs. The mammals will wait, their time hidden. Out of the storms, out of the poison, out of the extinctions, a new balance emerges, fragile but destined to grow. The rains had broken the world, but they had also set it free. We speak of this 2-million-year storm with the confidence of hindsight, pointing to rocks and spores, to isotopes and fossils as though they tell the whole tale. Yet if you lean closer, if you read the record carefully, you discover how much is missing. The Carnian pluvial event is not a complete story etched into stone. It is a puzzle, half the pieces lost, others broken, some painted in coal. Or as we still struggle to interpret. What we know is vast, but what we do not know is vaster still. The first mystery is the question of cause. Was it the volcanism of the Central Atlantic magmatic province that unleashed the rains? Or were the storms already building, fed by subtle tectonic shifts, with eruptions only amplifying what had begun? In the rocks, gases rise like ghosts. Carbon dioxide, methane, sulfur dioxide. But these signatures alone cannot tell sequence. Did the atmosphere tip first, pulling the skies into endless weeping? Or did the fires of the earth rupture the balance, forcing storms into permanence? We cannot yet say. Another riddle lies in rhythm. Did the rains fall without pause for 2 million years, an unbroken curtain across the world? Or did they come in pulses, decades or centuries of storm followed by intervals of uneasy calm? Oxygen isotope records suggest cycles, fluctuations echoing like the planet's heartbeat. But cycles measured in stone are blurred, smeared across time. A layer of shale may represent a decade or 1,000 years. To us, the distinction matters. To the creatures of the Triassic, every fluctuation was a lifetime. Then there is the question of scale. Were the rains truly global? The red beds, the fern spores, the isotope shifts all appear across multiple continents, suggesting a worldwide deluge. Yet patchwork evidence hints at exceptions. In some regions, certain species lingered as though spared, pockets of stability amid chaos. Could there have been refuges, valleys where storms fell lightly, coasts where ecosystems endured? Or did the catastrophe truly blanket Earth without escape? The debate continues, each new fossil bed raising more questions than answers. We do not fully understand the chemistry of the poisoned rains. How acidic were they? Some models suggest gentle leaching, others imagine torrents strong enough to strip forests in weeks. Did acid storms burn skin and dissolve shells, or were their effects subtler, cumulative across centuries? Fossilized soils bear scars of weathering, but the details remain elusive. Each raindrop is lost, each pool evaporated, leaving us with only mineral ghosts. The oceans, too, hold mysteries. We know reefs collapsed, anoxia spread, and blooms suffocated seas. But how deep did the suffocation reach? Some argue that entire oceans turned stagnant, black waters stretching across basins. Others believe the devastation was shallow, confined to coasts, while deep seas remained resilient. Hydrogen sulfide, that specter of toxic gas, lingers in debate. Did it truly breach into the air, poisoning land as well as water? Or is it a phantom conjured by chemical signatures we misread? We cannot be sure. Even the winners of the deluge hold secrets. Why did dinosaurs succeed where others failed? Was it truly their lung design, their air sacs, their agility, or were their victories more a matter of chance, of being in the right place at the right time when ecosystems fell open? Fossils tell us they expanded, yes, but fossils cannot whisper intent, cannot show us behavior, cannot reveal the subtle struggles of survival. We see footprints, but not the hunt, bones, but not the breath. And what of the mammals? Small, nocturnal, insect-eating shadows at the time. They endured, but how? Was their survival the product of physiology, or simply their obscurity? Did their burrows protect them from acid rain? Did their diets shield them from collapse? We know they lived, but not how they lived. Their survival is a gap as intriguing as the rise of dinosaurs itself. Scientists argue, too, about timing. Some propose the Carnian pluvial event lasted precisely 2 million years from start to finish. Others suggest a series of smaller events stretched over longer spans, stitched together in the rock record like separate storms, mistaken for one. Our clocks, based on radiometric dating, are precise, yet imperfect. Their margins wide enough to blur detail. Did life endure one long deluge or several? The answer hides in layers we may never fully resolve. There are mysteries of absence as well. Fossils of some creatures vanish suddenly, with no gradual decline recorded. Did they perish overnight in a catastrophic surge? Or did they fade slowly, their final traces lost to erosion, their graves unmarked? The fossil record is biased toward survival. Only the preserved are remembered. Countless species left no bones, no spores, no shells. They lived, they died, and they are lost forever, their stories erased. The true scale of extinction is unknowable. Odd hints also suggest that not all storms were the same. In some sediments, charcoal layers show fire even in an age of deluge. Did lightning ignite forests that somehow burned despite rain? Were there intervals when storms relented, leaving land dry enough for fire to rage? These paradoxes unsettle neat narratives. The deluge may not have been a uniform curtain, but a patchwork of contradictions. Fire amid flood, life amid ruin, calm amid chaos. And what of the human echo? We wonder if such storms could come again. We measure carbon dioxide rising in our own age. We watch seas warming, storms intensifying. Could we, through our own industry, awaken echoes of the Triassic deluge? Some scientists say no. The exact conditions of camp volcanism are unrepeatable. Others caution that while the details differ, the pattern, greenhouse gases, hydrological intensification, acidification, is disturbingly familiar. The past is both distant and near, warning us in a language of stone. Pause here and listen to the unknowns. They hum beneath the certainties like undertones beneath music. We know the rains fell, but not their rhythm. We know life shifted, but not every reason why. We know ecosystems collapsed, but not how deeply, how universal. Why the Carnian pluvial event is both the best recorded rainstorm in Earth's history and a mystery still unfolding. Science thrives in this space between knowledge and ignorance. Each fossil unearthed, each isotope measured, is not an ending, but a question. A fern spore tells us ferns surged, but why here? Why now? A bone tells us dinosaurs expanded, but what drove their steps? Every discovery sharpens the picture, yet reveals how blurred the edges remain. Imagine holding a fragment of shale in your hand, red with iron, marked with spores. In that fragment lies a storm 230 million years old. You can feel its weight, trace its texture, measure its chemistry, but you cannot see the thunderclouds. You cannot hear the rain. You cannot know the eyes of creatures who lifted their heads to a sky that never cleared. You know the fact, but not the feeling. That gap, that mystery, is what lingers. The unknowns of the deluge remind us of humility. We stand on a planet that has reinvented itself many times, each reinvention leaving both scars and silences. We can read the scars. The silences remain. They invite us to wonder, to imagine, to accept that the Earth holds secrets beyond comprehension. And so, the deluge is both story and riddle. A rainstorm we know intimately and yet incompletely. A catastrophe explained in part and obscured in part. Its unknowns are not failures. They are invitations to dig deeper, to imagine wider, to respect the immensity of time. The rains have stopped. The Triassic storms are long gone, their thunder silent, their lightning only a memory pressed into rock. Yet when we look at the world around us, at the restless climate of our own time, it is hard not to hear faint echoes of that ancient deluge. For the Earth remembers, and in her memory lies a warning. What has been can be again, though in forms unfamiliar, shaped by the hand of humanity. We begin with carbon. During the Carnian pluvial event, volcanoes tore open the crust and released staggering volumes of carbon dioxide into the air. The atmosphere thickened, the greenhouse effect surged, and the planet's hydrological cycle spun faster and faster. Warm seas evaporated more readily, skies grew heavy with vapor, storms intensified. Rain fell in torrents beyond the scale of anything living creatures had experienced. That spiral, that chain reaction, is etched in the stone. Now glance at the present. Industrial smoke rises. Cars and factories exhale invisible gases. Forests burn and release the carbon they once held. Our atmosphere, too, is thickening. In just a few centuries, an instant in geological time, human beings have raised carbon dioxide concentrations to levels not seen for millions of years. The numbers climb, the planet warms, and storms gather strength. Hurricanes deepen, floods grow more frequent, droughts bite harder. We are not yet in a deluge, but the echo is unmistakable. Consider the oceans. In the Triassic, endless rains carried nutrients into seas, fueling algal blooms that collapsed into suffocation. Reefs died, waters turned toxic, Today, rivers flush fertilizers into coasts, creating dead zones in the Gulf of Mexico, in the Baltic, in China's seas. Coral reefs bleach under acidifying waters. The chemistry is different. The causes human instead of volcanic, but the pattern is hauntingly familiar. Excess leads to collapse, abundance to suffocation, and the rains themselves, already they shift. The Earth's hydrological cycle is once again accelerating. Warmer air holds more water. Storms, when they come, are heavier, more violent. Floods devastate cities. Monsoons intensify. At the same time, droughts lengthen where rains do not fall, just as in the Triassic pulses of storm and silence alternated with cruel irregularity. The balance falters, and volatility becomes the new climate. Scientists draw the parallels carefully but firmly. The Carney and pluvial event teaches that sudden injections of greenhouse gases can destabilize climate on a global scale, driving extinctions and reorganizations of life. The difference is scale and speed. Volcanoes bled carbon for millennia. We pour it out in centuries. The tempo is faster now, and that acceleration may make adaptation harder, extinctions sharper, webs of life more fragile. And yet, as sobering as the echo is, it also brings perspective. Life did not end in the Triassic storms. It stumbled, it suffered, but it endured and rebalanced. New rulers rose, forests returned, oceans found new rhythms. If Earth survived that deluge, could she not survive ours? She will, but the question is whether we will recognize the shape of her survival. Dinosaurs benefited from the Triassic collapse. Humanity may not be so fortunate. Imagine the lessons carved in stone speaking to us now. Carbon matters, the rocks whisper. When too much fills the sky, the waters will rise. Storms will multiply, ecosystems will unravel. They warn, but they also remind. Life adapts, it changes, it carries forward new forms. The warning is double-edged. Earth's survival is not in question, only the survival of particular lineages, particular ways of life, ours included. Pause and picture a modern city during storm. Streets drowned, subways flooded, skies thick with rain. Now overlay the memory of Triassic plains drowning under deluge, of forests falling into rivers, of oceans suffocating. The scale differs, but the rhythm is the same. Storm upon storm, silence upon silence, a planet reminding us of her power. Odd hints deepen the resonance. Some models suggest that during the Carnian event, carbon dioxide concentrations reached levels that, if our emissions continue unchecked, humanity could replicate within centuries. The numbers align disturbingly. We may, unwittingly, be pulling the same levers Earth pulled during volcanic convulsions. The difference is intent. We do it not through molten stone, but through the machinery of civilization. And like then, winners and losers will emerge. Some species will vanish, unable to adapt. Others will thrive, exploiting niches created by upheaval. Already we see it. Corals struggling while jellyfish multiply, amphibians declining while invasive generalists spread. The pattern repeats, a cycle older than humanity, older than continents. There is comfort here, but also unease. Comfort in knowing the Earth has endured worse, and unease in realizing her endurance does not guarantee ours. The dinosaurs rose from storms. We may find ourselves diminished by them. Still, knowledge is power. Unlike the reptiles of the Triassic, we can read the rocks. We can see the parallels. We can imagine futures. The unknowns remain, but the echoes are clear. We stand at a threshold, holding the memory of ancient storms as both warning and guide. Close your eyes now. Hear the distant rumble of thunder. Not just the thunder of today's storm, but the echo of storms 230 million years past. Smell the sharp tang of rain on hot asphalt and let it carry you back to rains on red clay plains. Feel the wind pushing at windows and imagine it sweeping across Pangaea, tearing through fern forests. The past is not gone. It breathes in the present. It shapes our choices. It waits in stone and air alike. The Carnian pluvial event is not just history. It is prophecy written in rock. It tells us what endless storms can do, how ecosystems collapse, how life reshuffles. It shows us resilience, but also fragility. It whispers to us as we pour our own carbon skyward. You have seen this story before. You know its rhythms. You can choose how it ends. And so we listen. Some hear despair, others hear resolve, for the echo is not destiny, it is warning. The rains of the Triassic do not demand that we repeat them. They invite us to act differently, to write another ending. But whether we heed them or not, the it will continue. The sky will carry storms. The seas will find balance. Life will reweave itself. The question is only what place we will have in that tapestry. Will we endure, as dinosaurs once endured, finding advantage in change? Or will we be among the lineages the rains wash away? The echo hums in the background of our age, a reminder written in stone, in storm, in silence. At last, after 2 million years of endless thunder, the skies began to clear. The storms slackened, the clouds broke, and shafts of sunlight pierced through, touching a world transformed. Imagine that first morning of stillness after ages of downpour, the silence so vast it must have felt alien. For countless generations, creatures had lived and died under curtains of water, never knowing a clear horizon. Now, for the first time in millennia, the air was light enough to breathe without weight, and the earth lay drying beneath the warmth of sun. The landscape that greeted that light was unrecognizable. The deserts of early Pangaea were gone. In their place sprawled plains rich with mud, forests half reborn, marshlands glistening like mirrors scattered across the land, rivers carved deeply into valleys, new lakes gleamed in depressions where storms had gouged the crust. Oceans, though still recovering from suffocation, reflected the dawn with a strange, metallic sheen. The earth was no longer the one that had entered the deluge. It had been remade. For the old rulers, there was no return. Amphibians, once lords of wetlands, had been reduced to remnant forms, shadows of their Triassic grandeur. Rhynchosaurs had vanished altogether, their beaked skulls left as fossils in red clay. The crocodile-kin archosaurs lingered in diminished numbers, stripped of their Triassic dominance. The world they had ruled had drowned, and they could not reclaim it. But for the survivors, silence was opportunity. Dinosaurs, small and resilient, stepped into the quiet. They spread across plains, moved into forests, claimed niches left open. Within a few million years, they grew larger, more diverse, more powerful, until their footprints marked nearly every landscape. The deluge had not been their death. It had been their cradle. The storm had chosen them, not intentionally, but by the cruel lottery of survival. They were now poised to become the giants of the Jurassic, to rule for over 100 million years. Forests, too, returned, though not as before. Conifers adapted to new soils, cycads spread, and ginkgos unfurled their fan-shaped leaves. Ferns continued to surge after every disturbance, carpeting clearings with green before retreating once more. The balance between plant lineages had shifted. Ecosystems were rewoven with new textures, new hierarchies. What once had been stable deserts and sparse vegetation was now a patchwork of forests and floodplains, dynamic, evolving, alive. The oceans, wounded by anoxia and acidification, began their slow recovery. Plankton diversified, setting foundations for food webs that would sustain marine reptiles and future fish lineages. Reefs would take millions of years to return fully, but the sea was no longer silent. It pulsed again, cautiously, with life. The scars of collapse lingered, but resilience had begun to stitch over the wounds. And in the shadows, mammals endured. They did not yet rise, but they persisted, small and overlooked. Their survival through the storms was not dramatic, not visible in dominance, but steady. They bided their time in burrows, in undergrowth, in niches ignored by dinosaurs. Their story, too, had been shaped by the storms. The resilience they carried would one day matter, long after the dinosaurs themselves fell. The long silence after the rain was not absence. It was renewal. It was the planet inhaling after holding its breath for ages. Each drop that had fallen was now memory. Each storm had left its mark in stone, in soil, in the genes of survivors. The world low, oaked forward, but it carried within it the echoes of 2 million years of deluge. Scientists today trace this silence through strata. Above the red beds of storm-weathered clay, younger layers appear, their chemistry altered, their fossils new. Diversity rises again, different from before. Trackways show dinosaurs spreading widely. Pollen shifts reveal new forests. The earth, in its patience, reveals its resilience. The silence is not emptiness. It is the first note of a new symphony. And yet, questions remain even in this calm. How quickly did recovery come? Did silence fall abruptly or fade slowly, storms retreating in fits and starts? Did survivors thrive immediately or stumble through unstable centuries? The rock record, precise yet incomplete, hints but does not confirm. We know the storms ended. We know the silence followed. The details remain veiled, hidden in the fog of time. Still, there is beauty in imagining that silence. Imagine walking on a Triassic plain, the ground soft but no longer waterlogged, the air damp but clear. The sky stretches blue, startling after ages of gray. Insects hum, ferns spread across open spaces. In the distance, a small group of dinosaurs moves lightly across the land, their bodies slender, their steps sure. They pause, lift their heads, and gaze at a horizon free of rain. For them, it is not silence. It is freedom. The rains had rewritten creation. They had culled lineages, reshaped landscapes, reorganized ecosystems. They had ended worlds and begun new ones. Their absence now was not merely relief, it was transformation complete. The storm had passed, but its legacy would shape life for millions of years. Dinosaurs would rise to dominance. Mammals would wait. Plants and oceans would adapt. The web of life was fragile still, but it was new, and in its novelty lay strength. And for us, the silence after the rain carries its own message. It reminds us that catastrophe and renewal are twin forces, inseparable. A storm destroys, but the silence that follows allows rebirth. Life does not return unchanged. It is altered, scarred, but also reimagined. The Carnian pluvial event was both an ending and a beginning. Its silence not emptiness, but possibility. Now let us return gently, slowly, to ourselves. The rains of the Triassic are gone. The skies above us today are not theirs, but they carry echoes. The storms of our own time rise, heavy with carbon, heavy with consequence. But silence, too, will follow, one way or another. The earth will endure. The question is, what will endure with her? So breathe. Feel your lungs fill, as dinosaurs once did under heavy skies. Feel your feet against the ground, as forests once rooted after floods. Feel the silence around you, a silence filled with possibility. The rains have ended, the storms have passed. Life continues, and in that continuation lies hope. The story of 2 million years of rain is not only a story of ruin, it is a story of survival, of resilience, of the endless weaving and reweaving of life. It is a reminder that silence always follows storm, that light always follows shadow, that endings are beginnings in disguise. And so, as you drift now toward rest, let the silence after the rain cradle you. Let it remind you that storms, however long, are never eternal. Let it soothe you with the knowledge that life, though fragile, is enduring. The rains fall, the skies clear, and the world is remade, always.